Radhe Radhe. So in this video I'm going to discuss the minimum number of flips to make the binary grid palindromic part 2 problem, which often today's lead code challenge. If you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. The problem is very simple. You're given a grid and it is a binary grid, and what you can do is you can flip like elements of the grid so that it becomes palindromic from the perspective of rows as well as columns. That is basically you have to make the whole thing symmetric. Now this will be easier to understand with the help of this diagram. So what you can do is you can divide the grid into 4 parts, and every point should be symmetric on this line, symmetric on this line, as well as this line. So that is 4 points should be symmetric. Now how you're going to do this? So if you're going to divide it, so it will be from 0 to n by 2 and 0 to m by 2. That is this position. Okay, you're going to deal with this position because the remaining are by default dependent on this. Okay, now there is one tricky part, that is, what if the number of ones after doing the whole thing is not divisible by 4, because it is given in the question that it has to be divisible by 4. So you have to check whenever, like, you have to first like divide this. Since you're doing this like this, so it may happen that since whether you're dividing this like this, so there's a middle strip, okay, and there's a middle strip over here. It may happen. When it is going to happen, it is going to happen when the number of rows is odd or when the number of columns is odd. So this is the middle strip. Okay, in the middle strip, remember one thing: if the middle element, the middlemost element, if it is 0, it will remain 0, and if it is 1, it will become 0. Okay, so basically if it is 1, it becomes 0, and if it's 0, it remains 0. So you have to change this no matter what. Okay, no matter what, you have to change this. But apart from this, let's say in the strip there is one element 0 over here, and the symmetric element to it, it is 1. So you have to make it 0 0 or 1 1, right? But you don't know what to make, 0 0 or 1 1. So what you can do is you check if this flip thing, while performing this flip thing, if this is in the symmetrical line, or let's say 0 1, or it may happen like this also, 0 1, something like this. Okay, just the fact that both of them are symmetric on this line or this line. Okay, so you can see the number of symmetric plus plus. Okay, that is whenever you're performing a flip, so you can either make it 0 0 or 1 1, right? So you have to, so what is the number of symmetric flips? It is basically the number of ways you can make it 0 0 or 1 1, right? So once you're done with this, well and good, fine, you know this answer. Now you're going to check for the symmetric strip, okay, and check the number of ones and check the number of zeros. Remember one thing, since these were, we were like taking 4 elements into consideration, so for these it will be obviously divisible by 4. But the main problem occurs at these positions. Okay, now you have to check that whether the ones, if it is divisible by 4, well and good, you can come up with the answer directly. But if it is not divisible by 4, okay, now let's say when you're modding it with 4, it becomes 1. So if it is 1, you know that you can simply go with the solution that just add 1 to it. Okay, that is, since there is one extra 1, so we can make that 0. Okay, and this will be happening whenever you're going to encounter this position. Otherwise it is not going to happen. Okay, so basically you won't have to deal with this this situation if you're doing this 1 to 0 or the thing. Okay, at the symmetry, at the middle position, if you forget to do this, so you have to encounter this. So you're just going to add 1 to the answer. Okay, now let's say if mod 4 is equal to 2. Now if it is equal to 2, so there is a very interesting thing about this, that is, if it is equal to 2, that means that you have to either, let's say there was something like 0 1 1 1. Okay, these two were right. Okay, but there was a problem over here. Or let's say sorry, there was a problem over here, right? I'm sorry, this is going to give you the answer of 3. Okay, like I made a mistake doing this. So let's say 0 0 1 1. Okay, now over here you can see that it is having 2. So if it is 2, you're going to make it answer plus equal to 2. These two situations are very easy. But what if it is 3? Okay, so that is somewhat like this. Okay, if it is 3, you can make it answer plus plus, right? But there is a situation over here. Okay, over here also, over here there is no situation, but over here there's going to have a situation. That is, so we are doing this 1 1 1 0. So we can do what? We can just replace this and make it 1, right? So we are well with the answer, that is answer plus plus. But there is a second situation. That is, it may become answer plus equal to 3 when the elements are 1 1 1. The strip elements are 1 1 1. Okay, and this will happen only if you don't consider the middle element, that thing. Okay, so if the strip elements are 1 1 1, so that time you have to make it answer plus equal to 3. So what is the best approach? Like, just consider the middle element and remove the exceptional cases beforehand. Or if you're not being able to remove those exceptional cases, you're going to handle those exceptional cases at this position and at this position. Okay, so that's it. Like, let me go for a dry run. For this is the middle strip and this is the middle strip. Okay, for the remaining elements 1 0 0 1. Okay, so what you can do is you can either make all of them 1 or all of them 0. It is like, for me, I will prefer making it 1 1. Okay, because all of the elements at the symmetry has to be 1 or 0. So since I am operating 2 times, so there are 2 number of operations. Now I am going to have only this thing. So you can either do the middle element and make it 1 beforehand, or if you're not going to do that thing, so you can count the number of ones in this position and check. We are going to encounter this thing, so that is answer plus plus. Go for answer plus plus. That is 1, that is 3. 2 plus 1 3. Now for this, there is no middle strap over here, but there's a middle strap over here. Okay, there's a middle strap over here. So for this element, you can make this 0, so that makes 1 operation, because that is the minimum number of operations that you can make. But there is a middle strap over here. Okay, there is 0 1 strap. So what is the number over here? It is going to be 1, right? So it is 1. You are encountering this situation, so answer plus plus, that is plus 1. So we are getting 2. For this, the middle slab is like this. This is the middle slab. Okay, the vertical thing. So basically 1 1 1 1, all of them are having a symmetry. Okay, so there is 0 number of operations for the symmetry portion. Now for the slab thing, you're getting that there are 2 elements, so that is answer mod 2 4 equal to 2. So answer plus equal to 2. Answer plus equal to 2. Okay, so I hope this is clear. So that is from my side. If you still have any doubt regarding this, you can ping me up on Instagram. That's it. Thank you.